Our strategy is to infuse AI in everything we do, right? It's not just AI as a product line, but infuse
Mhm.
AI in everything we do because that's what enhances the usability from a consumer perspective, right? When you actually make things better and they don't even know AI is happening in the background, right?
Right. Hi, my name is Junko Yoshida. I'm the editor-in-chief of the Ojo-Yoshida Report. Today in the Tech Vision, we have a great guest from Synaptics. His name is Satish Ganesan, and he's a senior vice president and general manager of Intelligent Sensing Division at the company. But he's also chief strategy officer for Synaptics, which I told Satish, that's a very laudable the title that you have, Chief Strategy Officer. Really? Tell me about what you do first.
Thank you, Junko. Thanks for having me on. It's an honor, and you're doing a great job for the industry by the journalism. So I wanted to laud you on that as well. But generally, I mean, I think I have a dual role. So in the chief strategy officer role, I kind of oversee, the product portfolio and the strategy for the company and assist the various divisions and so on in this. So it's kind of more
Yeah,
of an assistance role in the strategy of the company,
yeah.
including mergers and acquisitions and so on and so forth. But as a SVP and GM of the Intelligent Sensing Division, as you're aware, our company has, three pillars that define any product, and that's how we are also defined. It's sense, it's process, and it's connect. So if you think about any device or a car or anything else like that, it has three functions. It has a sensor, it has a processor, and it has connectivity. And I take care of the sensing portion of the company. So in terms of sensors, in the sensing portion, we do a variety of products out there. But in the markets of PC, automotive, and mobile phones, across touch, display, and any sensors there, haptics, and so on, that part of the division is what I'm responsible for as the general manager of that division as well.
All right. Thank you very much. Before we go on, I just want to frame our conversation why I thought at Ojo Yoshida Report, why we thought this is a actually kind of important story because we, the reporters, always write about edge AI in the context of IoT, which is important. But
Hmm.
I think this is a story for the first time Synaptics is bring to the table. Let's bring edge AI inside the personal computer.
Yep.
Am I getting this right, Satish?
Yeah, yeah. I mean, I think there's two rages going on, right? So there is the as you all are aware, there's an AI PC revolution going on
Right.
where everybody's talking about the main processor, and with generative AI being the use case right now, the whole use case is about how many TOPS can I put in the main processor, and can I run Copilot Plus on the PC, and can I basically assist you as a personal assistant in everything that you do, right? That's kind of
Right.
what the revolution on the PC side is. And when everybody else talks about edge AI or embedded AI, that we also do in our processor segment of the
Sure.
equation, they talk about IoT devices and how to make them intelligent and how to
Right.
add intelligence there to make the user experience better. But if you
Right.
think about it, that's a greenfield area where people are figuring out the use cases and so on. But if you bring it back to the personal computer, so you talked about this generative AI and so on, but the
Mhm.
whole point is edge AI in a PC is there's all of these human interfaces that we have in a PC. We have the touchpad, we have the fingerprint, we have the screen, right? We have a smaller camera on the other side. And can you do more intelligent things? Can you apply AI processing and inferencing on all of this data that we have to make the user experience better? So think about the edges of the PC itself rather than tying it and tethering it to the operating system. Even you're outside the operating system and you're first interfacing with the PC through the touchpad or the keyboard or you're looking at the camera and doing all of these stuff, what can you do better there and how can you enhance the user experience? Now
Yeah.
that is edge AI in a PC, and that's kind of what we want to focus on, which
Yeah.
is which is not the mainstream focus, if you will.
Yeah. But that's the kind of subtle, but I think very useful things that you guys doing. But before diving in, tell me, you just came back from Taiwan, right? Tell
Yeah.
us about how was Computex? What was your takeaway? Let's start from there.
Sure. Computex was, I think the attendance at Computex was, I believe, it looked like it was the highest attendance in a long time. And from what the chatter was, everybody felt like it was the highest attendance the last 10 years. So it's a very vibrant show this time. So a lot of partners, lot of customers, lot of interactions. It was extremely busy. So it was very good to see, right? It was a very vibrant Taiwan environment. So it was actually very good to feel and see.
Yeah,
But the whole talk of the show, like I was actually indicating in my first part of the thing,
yeah,
was AI was plastered all over the walls for a PC show, right? So it's kind of a it was a very interesting and a revolution in the PC space. So the excitement is, if you think about it, everybody is announcing an AI PC line. Pretty
yeah,
much every customer of ours, and every main guy like a Dell or HP, and Acer and Asus. If you think about any PC maker, they're talking about how are they going to implement an AI PC, and so that was all the show. The show was all about that. It was about whether it's a Qualcomm PC or an Intel or an AMD, or is it an NVIDIA gaming GPU that has more tops on top. It was all about
right.
the AI revolution. So it was pretty exciting show.
Yeah. No, that was the talk of the town, and that's what we all read about. But tell me, I think where your company comes in, Synapses comes into the PC market from a different angle, and I'd like to delve into that during this discussion because it's really the AI in the embedded space, or I think I should reframe it as like you're sort of advocating distribution of AI processing inside the personal computer.
That's right.
So good, good. So tell me how are you going to differentiate yourselves and what have you got?
Yeah, I mean, I think we have some exciting things. So I think it's a interesting point, because we have a processor line and we have done all these acquisitions in the past, and we have all the elements of sense, process, and connect. One of the things you talked about and we are focusing on was, hey, there's edge AI processing that we're doing for IoT devices. But
Hmm.
what that has let us do is create a framework for understanding data sets and able to train these data sets for particular models and compile it to our chipsets, right, in an optimal way, so you can deliver good AI inferencing performance at a low power with a lower speed CPU that doesn't have teraops but maybe has gigaops or even megahops, right, and so on. So you have different flavors of these processors. So the idea is, can you have these experiences, or these elements where you can compile a PyTorch model or something like that and take it onto the edge elements. That's what our processor taught us very well, and we trained very well in that. And very few companies have that training. Now, the whole thing is we're taking that training and saying, okay, now we can actually take the devices that we are in today already, right? We have a good market presence in these areas. And
Right,
how about taking it to the edges there? Because that really enhances the user experience for all of the users. So an example, let me start with an example of that.
yeah.
So, Synaptics, the tradition of Synaptics is, hey, we were in touchpads, right? So,
Hmm.
and pretty straightforward interface. People think it's all done, right? Typically, it's all done, but there's a lot kind of revolutions happening in the touchpad side as well. You'd notice that there's more haptics in touchpads, right? So there's things that are happening, and touchpads are becoming longer and wide, longer and bigger as well. And you can think about things like collaboration pads where icons show up on the touchpad itself. So if in a call like this, I can just press these icons to mute myself and things like that. So the things like that are happening as well.
Right.
And now, if you have all of these things in the touchpad, and think about you're using your fingers, and sometimes your palm grazes this, and you probably had this experience. Your palm is you're resting your palm on a larger touchpad,
Yeah.
and the mouse moves or the cursor moves or your window changes or things like that, or you're having ghost gestures, if you will.
Right.
And differentiating between a palm and a finger, especially at the edges of the touchpad, because that's where it is.
Yeah.
the palm could look like a finger, right? Because it's like a part element of it. Now, how do we? It's a simple. It looks like a simple problem, but eliminating that touch and differentiating that between a palm and a finger would be good to have. And traditionally, it's done by procedural algorithms, and it's not accurate. It's not perfect because
What do you
everybody
mean by
has
procedural algorithm?
procedural algorithms are, we have data and we basically say, hey, if it goes beyond this thickness, it's this finger. If it goes
Oh,
less than this thickness, it's the palm, and things like that, right?
yeah,
Now that's great, but it doesn't work for everybody, right? There are different kinds of people with different sizes of hands and palms and things like that.
yeah.
And if you think about, hey, can we actually utilize the data set that's available by utilizing these touch pads? Because now I have a data set, and train these data sets for a variety of hands, and then say, hey, this is typically a palm and a finger touch at the edges. Now I can actually calculate all the data sets, and then with these data set train algorithms, and then apply the inferencing real time. So now when you're actually using it, you actually know the intent, and it's not a palm or a finger, and you can actually do the right thing with AI algorithms in place. That's the first generation. We actually have that out already. We showed a demo at Computex. We already have the
Okay,
first generation of that, and we can see that the improvement is dramatic. In fact, we have it in the high 90s% of actually accuracy for this one. But the next level of accuracy becomes, you can actually train it on a per user basis and say
yes,
your finger, your stuff, and you can add security now in terms of saying, oh, it's not your hand. Let me see what I would do with the screen. Do I need to understand it's somebody else's hand? Do I actually give access and things like that? So a multi-factor authentication, if you will, with something as simple as your hands and the fingers and the usage patterns, right? Saying, hey, there's
yeah.
somebody else using your stuff. So you can see that's the next generation of ACM AI. So it's actually all happening at edge. It's
Yeah,
minimum launch. It's not doing generative AI, so you don't need that level of processing.
yeah.
But it actually uses your own input to do it, and it can also do it outside of the operating system. So you're actually secure in your
Right,
in your usage as well. So you don't have to basically be worried about hacks and so on. You're
right,
secure as well. So that's one example of such a use case. A
right.
fingerprint is something that we do today already, which is another example, which fingerprint by definition actually understands your biometrics and so on, right? So it
Mhm.
understands the sensor pattern. Security is very key here as well. So it goes outside the operating system. So your data
Right.
is not transmitted all over the place. It's actually within uh, the, the,
Within
the,
that.
the area itself. So,
Yeah,
it does the matching, but that's not the data that's sent across. So you can't hack that data either. So it adds a flavor of security if you do it at the edges too. And that's how we can help our customers differentiate, because now we give this flexibility and so on. Customers can have their own UI, own use cases. So now they can say, oh, I have these other additional stuff that you can do beyond the Copilot Plus that I will differentiate myself from my other competition. Eventually,
uh,
we'll provide these features to everybody, right? But it depends
yeah.
on how the UI, how they customize it and so on for them to differentiate. So that's
I
kind of what the concept of adding AI to the edge of the PC is, right? And so these are examples of it. And
Yeah.
there's one more example, but I'll let you ask a question before I go on.
Yeah, okay. So yeah, the I'm kind of struck by this, but you said that you already have a data set. How did you collect the data sets? Where do they come from?
Oh, the data set collection, actually, we run the data set collection. So, having people use PCs is kind of very common, right? So now what you have to do is, we started with just our employee base, and we
Mhm.
basically got the whole flavor of the employees to say, hey, collect all this data and optimize this. And the power of AI algorithms is very interesting. So we actually collected a small data set sample, maybe about just 50 to 60 people. So
Mhm.
we got their approval to get collect data sets across globally, not just here, globally, because people vary
Ah,
by region as well. Their things vary, right? Whether than India,
right.
Asia, US. So we got it globally and we trained it. And then
Yeah.
we deployed it. And interestingly enough, just by training that many hands, we actually improved the accuracy by, maybe 30% or 40% over the regular procedural stuff. And then the question now is, now we can ask users across the board to basically join the testing and use case and all of those things to say, hey, use it this
Oh,
particular way. Just like you train your finger for touch for phone, right?
yeah, yeah,
It's like
yeah.
that. So you can say, hey, that's what we can do, and get more data. And as you get more and more data, it becomes better and better. At some point, you don't need any more data because it becomes little gains
Right,
for that.
right.
But
Wow.
that's the flavor one. Flavor two is you can think about this training our customers using for giving a UI for training your own hand within your own touchpad, right? And then you get your specific customized use case. That's the future, right?
Oh, I see. That is fascinating. So how long have you been doing this? I mean, you actually foresaw the future of let's use AI, collect data, and improve our touch experience.
Correct.
How
And
long?
and if you I think you and I chatted a long time ago when we were doing our acquisitions and so on. And one
Mhm.
of the things that we had mentioned is, hey, our strategy is to infuse AI in everything we do, right?
Ah,
It's not just AI as a product line, but infuse
mhm.
AI in everything we do because that's what enhances the usability from a consumer perspective, right? When you
Right.
actually make things better, and they don't even know AI is happening in the background, right? For us, we want to utilize that to basically, gain more shares, sell more chips, right? Do what we have to do. But at the end of
Yeah.
the day, for the use case has to come from the consumer perspective. Am I actually benefiting from this whole thing, right? Is this
Right.
enhancing my user experience? And so that's kind of how we thought about doing it when we started that foray into, hey, let's acquire these assets that have AI in them. And as we collect them and so on, the intent was, infuse AI into everything we do. Since we have a
Oh,
processor line, embedded AI became a thing in itself, right? But
right.
we didn't lose the focus of taking and embedding AI into everything we do. So that's kind of how we think about it. And
Wow.
and and there's and we started with something called we wanted to go. Voice was the pretty much the starter of AI for embedded AI, and then it became Vision AI. So what do we do with Vision? And if you think about it, we started with Vision AI. We wanted to do embedded processors with Vision AI and so on. But the first use case for Vision AI is what we call UPD, or user presence detection. That
Okay.
basically is a small camera, a monochrome camera that we embed inside PCs. And this is actually shipping today, and some of the PCs use our products already in the
Wow.
market. They call it human presence detection and so on. So there's a small second camera that basically is in the PC that basically operates at a very, very low power. So you need a sensor that operates at super low power, not a full color sensor like we have right
Right.
now, but a very, very low power sensor where it can detect somebody like me, right, or you,
Yeah.
we perform AI algorithms with this monochrome or maybe slightly better image quality, right, but not
Mm.
not too high power sensor. But we can detect a person, we can detect who you are, we can do a face detect, we can detect whether you're looking sideways or whether you're looking at the camera, and based on that decide what to do with the screen, right? Do we dim it? Do we make it lower power? Do we turn it
Oh.
off? Can I detect an onlooker from the back, right? So then say, hey, I'll turn on the privacy settings and I'll do all of those things with this particular camera and user presence detection. So I know, and I can add a second layer authentication, just like I'm talking about here. Once I log in with my fingerprint and so on, I know it's me.
Yeah.
When I go back on and come back on, it's figured out, oh, I'm still here. I was present, but now I know I'm looking at it back. So I log you in because I know it's you right now. And so it's a multi-factor authentication that you can enable. But those things are Vision AI algorithms. And those are actually already implemented and shipping today as well. So we are actually in there, and you'll see more products come out next year that actually have this
Oh.
enabled in the PC ecosystem. So think about another edge, which is the camera edge. You have that's another human interface, right? And then you can think about the touchpad edge. You think about the fingerprint as the edge. Maybe the keyboard is edge in the future, right? All of these
Wow.
things are areas where we take existing algorithms or existing knowledge, but apply it to the base that we have. And at the
Right.
end of the day, that helps us expand our SAM, expand our content, increase
Yeah.
our content per PC or so on, and that's kind of our strategy on this area.
That's actually interesting. I actually worry about when I'm for example, in a flight. The person next to me is just watching my screen.
Yeah, yeah, and traditionally you put in a filter in there on
Yeah.
your old school is traditionally put a filter in
Yeah.
there and
Yeah.
and basically have that going. But
Yeah.
these days it's more about, hey, can I turn on privacy based on your position of your eye and your face? Can I turn on the privacy? And we talk about PCs, but
Yeah.
I also run the smartphones and the automotive segments, right? But if you think
Sure.
about the same thing, what we want, what automotive makers want is in a larger screen. When the driver is looking at certain things, they don't, and you're watching a movie because screens are getting larger, and the passenger is watching a movie on his side. Just say that's possible. They don't
Yeah.
want the driver to be able to see that. So based on the angle at which you're looking, they want to create privacy sections in your screen itself. Think about that as an edge AI. It's not going to be a part of the operating system. It's going to be happening at the edge, tied in with the use case itself, with the interface and the connection there. So how do you do that? Or based on the angle of the touch, I'll enable touch when you touch it with this angle, but not when you touch it at this angle, because now I know you're stretching, and I don't want you to do that because it's safety, right? So
Jeez.
those are use cases where, again, AI plays a great role because you can figure out all of these things in a much
Yeah.
more robust fashion. And I think
Yeah.
we so there's so many such use cases when you think about it in areas that we already have, and
Yeah.
that should give us differentiation in the markets that we play in, both for sustaining it and, in fact, growing it.
So I'm just dwell on this automotive example you just told me. This is something it's not done yet, is it?
No, it's not done yet. And
It's
so
not
and
done
so, I
yet.
mean,
I can
I don't
still
want to give
do
us
so.
too much of
Yeah.
our secret sauces out, but yes, it's not done yet. In AI is a little bit safer for us to give our secret sauces out because it's not easy to do it. So
Right.
that's the other advantage that we have because of this processor and embedded stuff that we have.
Yeah.
It's not just easy to incorporate AI features and models and optimize it for running on your processor. People do
Yeah.
vanilla stuff, but to make
Yeah.
it run in a very low power profile with a limited set of memory and MIPS that you have, it's
Yeah.
not easy to go do it. But yes,
Yeah.
automotive, that's this features, they
Yeah.
exist in some different form. People are trying to do it as a from a panel perspective itself, right? Make the
Yeah.
panels themselves not show this thing, but that's cost, right? So, but if you can reduce the cost of the panel, but do it with AI with just the chips that you have, maybe that's lower cost, right? So now the question is, in this case, can you actually deliver the same features at a much lower panel cost than you did it before? That's kind of the equation.
All right. I'm gonna bring the conversation back to PC
Yep.
because I think this whole idea of distributing AI processing throughout the PC is still new. Are you the it's like we kind of think, as you said, as you yourself said, when we talk about AI PC in the context of what have been announced, is always about, can you do chat GPT on your PC? Can you do this? I mean, it's sort of how do you make use of the central compute, whether it's
Yep.
a GPU, CPU, DSP, NPU, or whatever, right?
That's right.
Now, you know, I'm old enough to remember when in the PC industry, every time some new features come in, first it was like adding graphics card or adding video card. It's always sort of adding things to make PCs better. But eventually, companies like Intel started to integrate everything in the motherboard. Are you worried about that? Whatever you're doing in the distributed AI processing might be eventually integrated into the central compute.
Yeah, I mean it's a very good question, right? And in some cases that might happen, but if you think about what I talked about, right? We are talking about things where the user, where we play in the edges, where the user first interacts with the system, where maybe the operating system hasn't kicked on itself. So maybe you're actually at a state where you're in the deep sleep mode or in a sleep mode, and our first interaction is, I'll touch the touchpad or I'll use the fingerprint, or actually this low power camera is still on trying to detect me. So I've not kicked in the main processor yet, or actually that's number one. So we
Yeah.
still are at the edge. So we can operate at ultra low power that does not impact your battery, because as soon as you have to turn on even a power island, say these guys actually can do power islands and so on, you're actually going to increase the gear. If you
Still,
think about
yeah,
gearing systems, we are at the lowest gear of power. You're going to
yeah,
notch it up, and that decreases the days of battery life if you keep doing that and running it in, right? So that's number one.
yeah,
Number two is, I talked about security, right?
yeah,
So the main thing is, for some of these things you want to act within the operating system when the things are turned on, but outside the operating system when things are turned off, right? Or the main processor is not on. So if you look at most of the central processing system, it's driven by, in the PC space, by the Microsoft ecosystem, right? So you have Microsoft, you have the Copilot Plus, and so on. So they're enhancing the use cases in there, and integrating that into, how to do even presence. Once you are turned on the main processor, you can do it with the Microsoft ecosystem. But the question is, can you operate outside of that when things are off, or actually the operating system is not running, because that's more secure, because you're going to hack the operating system. You're not hacking the chips. You're not hacking the edge parts of it. And so security starts playing a role. In fact, these things, I believe, will take more and more prominence as this happens, because now people are going to start talking about, hey, is this secure? Is my data happening? What's happening? Everybody knows what I'm doing with the OpenAI or ChatGPT and so on, and
Right.
everything is known, right? This is the new world we are in, and but basically, some things like your fingerprint, what you're doing, and so on, that we're talking about in ultra low power modes with very little processing power, that's available at the edges. So I see
Interesting.
actually the opportunities are going to increase as people see, hey, that is something that we need as well. It's
Yeah.
also a way in which the UI and the people like that outside the operating system, outside what traditionally Microsoft provides, is what our customers can use to differentiate. So I think if everybody is doing the PC, what is one PC versus the other PC, other than premium versus mid versus low? It now gives an opportunity with a secondary distributed processing to do what you want to do. So
Yeah.
there's even a chance that that processing becomes slightly more powerful, so people can do their own algorithms on top and value proposition on top beyond what we provide. And I
Yeah.
think that's going to be interesting, because that operates outside the ecosystem, which is the PC today.
Yeah, no, that's a very good point. Because if I were a PC vendor, it's like, all right, this is great. This whole AI PC era, everybody's gaga over it, right? But how do I sell my PC that's run the same operating system with the same chat GPT? I mean, how do I differentiate my PC from other PC manufacturers? That's a really valid point, I think.
Right, right. And
Yeah,
so our goal is to now make sure we can enable this. And from Synaptics perspective,
yeah,
it converges what we do, right? Even though we're doing processor space, and we're doing PC space and touch and automotive and so on, it converges what we do, because that's what the power we bring. And today we have every solution that we have, the touchpad, the fingerprint, this one, everything has a chip in there that's for certain functions, right? To enable the touch, you have a touch controller and so on. It has a processor with MIPS, with an
right.
embedded flash in there that runs those algorithms,
Yeah,
and things like that. You can think about the next generation of these things, presumably when the use cases become more common, becoming more powerful. And so
yeah,
you're able to run and more AI oriented, maybe with a neural net assist in there. And so then
right.
you start running things a little bit more. So I
Yeah.
see this as an opportunity and not as a risk.
Yeah. I think there's one thing that I forgot to ask you about is that, as you said, you are already in, your edge AI is already in mobile devices, IoT, and other things. So let's talk a little bit about the reuse of what you have already developed and how it could be useful. I think one of the things is that you guys, I didn't know this, but you guys are in the Samsung foldable mobile device, right?
We
That's not affordable?
we won't talk too much about it,
Oh, okay.
but I think we are developing. So just to be clear, today we play only in the candy bar phones, right? So today we play only in the flagship phones that are basically flexible OLED phones, because those
Okay.
things are very, very tough to do, because they are so thin, and there's so much of noise performance going on. And so they are that's where we are basically playing, because people cannot deliver algorithms easily for that one.
Oh,
And algorithms, these are just traditional algorithms to actually make it work and the noise performance work. So these are
yeah.
fundamental mixed signal architectures that are very good, and that's
Okay.
why we have a presence there. In that one, in the mobile market, things, there are simple things like, when you have your phone in your pocket, or when you have your phone next to your ear, when you bring it closer to your ear, our touch sensors, these are capacitive sensors, they can detect as you come closer to areas and so on. Now, the question is, can you detect you're getting closer to a body surface, which is kind of your face rather than something else?
Right.
And doing that in a when you have a lot of data sets with different users and so on, doing that in a way where you detect faces, it's called face detect AI or something like that. If you can detect faces as things get closer, then you can implement that as an AI algorithm that says, "Oh, I know it's a face, so I can actually turn on or off my phone because I
Oh,
cannot. I have to
okay.
turn off my phone when I keep it closer to the ear because I don't want to press ghost buttons, right? Because
Yeah,
that's touch enablement. So I have to
right.
disable touch, but I detect that with the touch, which is capacitive sensing that I have for my touch anyway, right? So
Oh,
that's kind of an example of an algorithm in a foldable setting or in anything else where we are making our foray. We'll talk about chips that we are doing for that market in the future.
yeah,
But I think things that we can do in that area are more because of our sensing and in these areas we can actually detect with our capacitive sensing like just like detecting a
yeah,
face and a phone, we
right.
can detect one display with another display as well as long as we are there on both sides. And once that's there, we can do many algorithms that are AI based that can detect the angle of the phone. Or in the PC side, if we are on the screen and the touchpad, we can detect the angle of the PC, and based on that, we can figure out. Oh, if sometimes when we're talking, we just do this to the
Yeah,
PC, but shut it down. We just close it down three quarters, and
yeah,
then start chatting, and then don't do anything about the PC. Should the PC go into sleep mode? I think it should. Should it
yeah.
go into standby mode if you stay for longer? Maybe it should, right? If it goes even closer. Similar to the phone, hey, you can detect the on or off. And
Oh,
today
wow.
there's typically an IR sensor in there that adds cost and so on. And you can think about, hey, with these AI algorithms and because based on the angles, we can actually do interesting algorithms in the phones where, when you fold the phone, you have a area where the hinges,
Yeah,
and you can determine based on the angle how bright I make that compared to the rest of the displays. And so now I can make it look like a clean surface. And
wow.
this can be done with AI. But those things are new stuff. I just gave you some new bits here, but those are
It's
not yet there.
in
So
the open. It's in
in the
development.
open, yeah,
Yeah, no, that's fascinating. This is like, I was telling you earlier that I just wrote an opinion piece about that. This AI PC thing is great, right? And everybody's excited, but at the same time, I have to ask myself, what's in it for me? I mean,
yeah,
really, I mean, it's like what will it do for me? And I think some of the things that you guys are talking about is really close home, hit close home, because it's like it's what I use every day. And if there's a better way to lower the power and protect privacy, I think that's good.
yeah. I appreciate it, and I think that's what we can't be an also ran right in this market. We don't want to be. We don't want to be. Our goal is not to compete with the big processor guys. That's
Yeah,
not who we are.
yeah,
Our DNA is edge, embedded, low power, with a minimal MIPS in there.
yeah,
What can you do, and how do you optimize these things? That's what we are doing our research on, and now take that and apply it to all the edge elements that are there within the PCs, within the phones, within the automotive,
yeah.
apart from the new markets that we are going after, right? So that's kind of what, if you think about, you asked me, what is the chief strategy officer role? That's kind of the strategy for us as we move
All
forward.
right. I think you passed the test for Chief Strategy Officer
There we go.
in
There
my
we go.
book.
There we go.
All
There
right.
we
Well,
go.
thank you very much for coming to the show, and we'll talk soon. Okay.
Pleasure as always, Junko. Thank
Okay.
you.
Bye.